Hello and welcome to this section of Introduction to Autonomous Systems. We are now going to start a new topic which is related to our ability to find an inference or a conclusion from a given set of knowledge statements or any other set of hypothesis space, and this idea is the concept of search. So, let us begin. Search in its most general interpretation is an activity that is intended to yield something specific that either solves a problem or helps in solving the problem, which means when we are searching, we either get the solution or we get a methodology of arriving at the solution. In either case, the purpose of search is served. And you will realize that search is inherent in any problem solving activity, and the basic philosophy is that you go through a large number of options for either solutions or for methodologies in the context of a given task. The result of any search activity is a solution or a method of solution which is supposed to be applicable for the problem that you are intending to solve. And that brings us to the important first step in this whole process is the formulation of the problem, and that is in some way is related to synthesizing a search strategy itself. That search, how to conduct a search itself now becomes a problem that needs to be first solved before the search can begin, which means we now need to create a search strategy, and to do that we first formulate the problem that needs a solution, which means depending upon the way we have put the problem statement, we will need to create a strategy and then we will apply the strategy to get the solution. So, these are the three important steps in ultimately coming up with the solution or a method of solution. So, the problem formulation, if we look at it, is nothing but a task of deciding what actions and the states to consider for a given goal, which means what are the states that we are interested in and what are the actions that are possible. So, basically it is a collection of those items or entities which define the problem that we are trying to solve. And please note that this formulation of a problem has to be in the context of the environment within which this problem has to be solved. For example, when we are talking about solving the problem of driving, the context is your environment is roads, other vehicles, pedestrians, signals and obstacles, blocks, one ways, all those together form the environment. This part we have discussed, I just thought I will refresh your memory. Of course, as we have also seen, environments can be of various types. So, let us first take it as a reasonably simple and idealistic environment which we assume that it is observable, it is discrete, it is known, it is deterministic and it is episodic. So, the problem formulation is nothing but a fixed collection of sequential actions. Because it is a deterministic problem, the formulation is nothing but a fixed collection of sequential actions that if you take these sequence of action, you will reach the solution. This is what the interpretation is. And the search activity is essentially looking at a sequence of actions that will result in achieving the goal. So, this is how the whole search can be broken down into just a sequence of actions. So, such systems are typically called open loop, which means we are definite that if we take these set of actions, we will get the solution and we will not worry about future percepts, which means we already have a well defined actions which will lead us to the goal, and we do not have to worry about what percepts we will get. So, there is no reason to have any corrective action. So, that is why the term open loop also is sometime applicable to this scenario. So, let us see, in case we want to formulate such a problem, what components will we need to consider. So, we will need to consider what is the initial state. We will need to describe what are the possible available feasible actions. We will need to know what is going to be the result of our actions that we are going to take, and we will have to define a test which will say whether we have reached the destination or the goal or not, and then the cost of each of the path options that we take. In case we want to do an optimal solution, we need to know what are the various costs involved. It is almost like saying that if you want to go from point A to point B, what are the possible actions, which means what are the possible driving directions that you can take. If I go in particular direction, what would happen, and how do I know that I have reached a destination, and how long would it take to go through each of those paths. So, this is highly intuitive, and you will find that these 5 elements define a problem, and in general they can be grouped as a single data structure, which is then treated as an input to the problem solving agent. So, this now becomes the way a problem solving agent would behave, that there is a problem which it has to solve. So, what are the characteristics of formulation? So, formulation is the first logical step in arriving at the solution, and as I just mentioned, it will also become optimal if the search strategies are able to provide a minimum cost solution. So, you have to look at search strategies which can give you a minimum cost solution. It is to be noted that any formulation activity is a model. Most of time it is going to be mathematical, and it will keep only the essentials as a part of the problem description. So, it is kind of an abstraction of the problem. So, I just want to give you an example to say what exactly we talk about or what we mean by problem formulation. So, this particular problem, what we call 8 puzzle, is a problem which is quite well known, and it has been used for many training exercises for how to define search and how to reach the solutions and what are the issues involved. So, this is very specific. It is actually a 3 by 3 grid containing 9 squares, in which 8 tiles numbered from 1 to 8 are arranged, and there is one space which is blank, or what we call the blank tile. Now, the requirement of this particular puzzle is that you have a start state which could be any number. This is just randomly chosen to be one particular distribution of these 8 tiles, and that after taking a sequence of steps, you should reach the goal state, which means the blank should come in one corner, top left corner, and the number should be arranged sequentially from 1 to 8. So, this is the problem that needs to be solved. Let us see how first we can formulate this problem using the 5 components that we have seen just now. So, in this case the 5 elements are: location of all 8 tiles and the blank space is the initial state, that where they are defines the initial state. Any state as you take the move is nothing but your a solution at each stage. Blank space movement is your tool that you are going to use, that where to place the blank, and the legal action in this case defined are given these 4 sets, which means a tile can go to left, a tile can go to right, it can go up or it can go down. So, these are only 4 legal moves possible, which means the diagonal movement is not allowed. The result of any action, which means the moment I move a tile, the result is a change in the location of all the tiles, and that becomes my result of any action. Matching of any state with the goal state, which means anytime I make a move, I check my current state with the goal state and see whether I have reached the goal or not. And number of steps taken to reach the goal state becomes my path cost. Now, as you can see, there are multiple options for moving the tiles. For example, you could move 2 down, you could move 6 to the left, you could move 5 to the right, or you could move 3 to the up. So, right in the beginning there are 4 possible moves. Now, once that one particular move is chosen and done, the state will change because the blank space will move somewhere else. And then there will be other possibilities of moves which you will consider, and as you keep considering those sequence of moves, at some point your goal state will be reached, and then you count the total number of steps that you have taken and say, okay, I took 25 steps to reach the solution. I am sure many of you would have dealt with Rubik cube. Of course, it is a lot more complicated problem and has lot many states, but the philosophy is essentially the same, that you start with some random distribution of colors on all the 6 faces, and then by suitable movement of the various colors, finally you end up getting those 6 colors on the 6 sides uniformly, and then you say, okay, I have solved the problem. And many times what you are doing is you are just randomly keep changing until you keep seeing where what color is going, and based on that you take the next step of action. So, it is something similar to that. Now, of course, this is quite straightforward what we have seen, solution strategy, that you just keep looking at moving the tiles and seeing where, and many of the search strategies that you will see are intuitive. For example, visual inspection is typically the best strategy that you use in order to arrive at the solution. You keep looking at where it are, and based on that you come up with. So, your percept is in the form of the visual input, that you see what is the state and then based on that you take an action. Real world problems are not this simple. They are lot more complex, and also their solution space is quite large. Sometimes may not be known also. So, the assumption that it is known, observable, all that is no longer applicable. So, for example, path planning or route finding in the context of mobile robots in an unknown building or in unknown space is just such a problem that requires a complex formulation and a large variety of search strategies to arrive at the solution. In this context of search strategies now, we are going to introduce 2 broad class which we are going to discuss further in subsequent sections. The first is called uninformed, or typically called the blind search, which means I do not know anything, I just keep checking everything until I find the solution. You remember we were talking about that knowledge based agent, and there we said that model checking is one of the procedures where model checking for entailment can lead to final inference, like finding a needle from the haystack. So, blind search, uninformed search is essentially like finding that needle in the haystack by checking everything. Other one of course is the informed search, where you do have some problem specific knowledge, which you make use of in order to proceed with the search, so that you reduce not only the search space, but also the search time. So, in the blind search, the problem statement or formulation, there is nothing else there. There is a problem formulated and now you go and do it. So, obviously solution will proceed from an initial state, and then we keep generating a successor, which is then tested. For example, the 8 puzzle that we just now talking about is essentially of this kind. We do not know anything about the problem. So, we just start from this initial based on the constraint that have been given to us. We generate a successor in the form of making one move, generating another state, and then we test it for the goal, and we keep doing this until we find that the solution or the next state that we have achieved is the goal state. We will look at both these in some detail. So, to conclude this part, search is essentially a concept of finding the solution of a problem, or in other words, actually finding that needle representing the inference in the haystack of knowledge base. So, this is our primary focus now in the context of search strategies. Of course, we know that specific algorithm will work better for a specific problem, and in order to do that, now we need to select a strategy keeping in mind the nature of the problem. We will find that sometime bringing in problem specific information will help manage search in a better manner, but in many cases in the new scenarios, your blind or uninformed search might be the only option available. So, with that we come to the end of this section, and we will continue with our discussion on the topic of search in subsequent segments. So, bye for now. Thank you and see you in the next segment.